Hi, in this video, I'm going to talk about the error of hypothesis testing. Okay, so none of the hypothesis testing are errorless. So there will be always some error. So what types of error? What are the possibilities of error? That's what we're going to discuss first. While testing the hypothesis, the decision is made based on the test statistic, which depends on measure from the sample. While doing so, two types of error may occur. One is type 1 error. We denote this by alpha. Okay, if one rejects the null hypothesis when it is true, we call it type 1 error, meaning rejecting the null hypothesis when it is true. That is error, right? Because it should not be rejected, but you reject it. So this is the error of accepting an alternative hypothesis when the result can be attributed to chance. It occurs when we are observing a difference when in truth there is none. Okay, so that's what the type 1 error. Type 2 error is if one fails to reject the null hypothesis when it is false, we call it type 2 error. It is called false negative. In other words, you reject the alternative hypothesis even though it does not occur due to chance. All right, so note is type 2 error is denoted by B. So type 1 error is denoted by alpha, and type 2 error is denoted by beta, not B, beta. Okay, so the quantity 1 minus beta. What is 1 minus beta? That is just the complement of beta, right? So what is beta? Beta is the fail to reject the null hypothesis when it is false. Okay, when the null hypothesis is false, you should be rejecting, but if you fail to reject it, that is the error. That is called type 2 error. 1 minus beta is, so reject the null hypothesis when it is false, right? Because the complement of fail to reject is reject the null hypothesis when it is false. It is called the power of the test, and which is 1 minus beta is probability of rejecting H0 given that H0 is false. Okay, so on table you can summarize that this way. So see, suppose H0 is true, null hypothesis is true. If you reject it, this is the type 1 error. If you do not reject it, then it is the correct decision, right? And when H0 is false, when the null hypothesis is false, then if you reject it, that is the correct decision you made. But if you don't reject it, then it is the type 2 error. So the complement of the type 2 error. So we denote this by alpha. This one is beta. So the complement of the type 2 error, 1 minus beta, is called the power of the test. So let us see an example that how do we find the power of a test by hand. But to find out the power of a test, we usually use software. Okay, so I'm going to do one example by hand. Okay, so you want to find out type 1 and type 2 error. So type 1 error is always alpha. So whenever alpha is given, that is the type 1 error. But I will follow the definition. Okay, so what is the definition of the type 1 error? So what is given here? Here is you have, so sigma is given as 3, n is 25, right? And then alpha is 0.05. Okay, so you are testing for mean. What is H0? H0 is mu equals to 25, right? And H1 is mu not equals to, mu equals to 20 and mu not equals to 20, right? So H1 is H0 is mu equals to 20 and H1 is mu not equals to 20. This is two-tailed test, right? All right. So when do you, so what is the type 1 error? So type 1 error, type I error is probability of rejecting H0, right? Reject H0 when H0 is true, right? H0 is true. H0 is true means the true value. Okay, the true value of H0 or the true value of the population is 20, but you rejected it. Okay, so what is the chance that you reject the true null hypothesis? So let's do that. Let us see that. So what is the critical value in this problem? So we are doing for the mean, right? So when will you be rejecting? Okay, so number 2, you will find out, let's say you will find out the test value G equals to x bar minus mu over sigma over root n, right? You see that? X bar minus mu over sigma over root n. That is the G. So you see that So you see that that will be x bar minus mu. Mu is what? Mu is 20, right? So mu is 20. Mu is 20 over sigma is 3 root n is 5, right? 3/5, right? That's what you get. That is the g. So when do you reject? So number 3, what is alpha? Let me do the critical value method. Okay, so alpha is 0.05. So two-tailed, right? Two-sided test means when do you reject the null hypothesis is if the test value, so if the test value fall on the shaded region, right? Because since it is two-sided, you will find out alpha half is 0.025, right? And that is 0.025. That is also 0.025. You see that 0.025. So it is that area, and this is also 0.025, right? Now, when do you reject this null hypothesis? You reject the null hypothesis if this test value either fall here or fall here. You see that? You reject, because you are saying that probability of rejecting 0 means you will reject that null hypothesis if that test value falls here or here. So what is that value? That value will be found by, let's say this is g alpha half negative, this is g alpha half positive, right? So what is negative g alpha half? It is, so it is q norm 0.025, right? And then 0.1, you will get negative 1.96. So this will be negative 1.96, negative 1.96. This will positive 1.96. So when do you reject? So you reject H0 if that g value, if g is less than negative 1.96, that test value, if this test value is less than that, or g is greater than 1.96, not 1.19, 1.96, okay? G is greater than 1.96. But what is g? Let's plug in that value. X bar minus 20 over 3/5 is less than negative 1.96, or and then x bar minus 20 over 3/5 is greater than 1.96. Now if you solve for x bar, then what do you get? You will basically get that x bar will be, x bar, you multiply this both side by 3/5 and then add 20. That's what you will be doing, right? You will get x bar is less than 18.824, and here or x bar is greater than 21.176. So in this situation, if g falls this side or that side, then you reject, which is same as saying if the sample mean is less than that or sample mean is greater than that, then you reject the null hypothesis, right? So let me note this down very bottom, and then I will find out the type 1 error from there. Okay guys, so let me do that. So as probability of rejecting the null hypothesis, okay, so that is p, okay, equals to p. When do you reject? If x bar is less than 18.824 or x bar is greater than 21.176. Given that H0 is true means mu equals to 20, right? That is H0 true means the true value of mean is 20. Now, how do I find out this probability? So what is this? There is or there, right? So either this or that, right? So how do you write down that? So it is either you will reject the null hypothesis if x bar is less than 18.824, given that mu equals to 20, right? Or you will reject the null hypothesis if a probability that x bar is greater than 21.176, given that mu equals to 20. See, there is x bar. You see that? There is x bar. So how do I find out this probability? To find out this probability, one way is you just change this to g by doing x bar minus mu over sigma over root n. Do that way. The other way is directly use p norm, because you are finding the probability. So you can directly use p bar, p norm. But there is one problem there. There is x bar. Okay. So if you have like probability that x is less than 20 with mu equals to, let's say this is 21. Okay. Mu equals 20, then it will be p norm, and then less than, right? So it will be 20 comma mu is 21 comma mu is 20, and then standard deviation is 3. You could do that way if it is like that, right? But if there is x bar, then by the central limit theorem, standard error at that time, if it is x bar, then the syntax for the R will be probability that, so p norm to find out that area, okay, p norm left of 18.82, so 18.82, mean is 20, mu is 20, but the standard deviation will be sigma over root n. If there is x bar, when you do the p norm, you will have to use sigma over root n. That will be 3 over 5. That's what you do. Okay, so whenever you are trying, but if you want to change this to g value, you can definitely do that to the g value. Okay, and just use that, and then plus, so it's the same thing. So here it is greater than, right? For the greater than, you do 1 minus p norm, and then x bar is the same thing, 21.176 comma 20 comma 3/5 sigma over root n, because that is x bar there. Okay, because of those x bars there, you need 3/5 sigma over root n. All right, so just use your R to find out what is that area. Okay, so what I'm trying to do here is, it is, let's say, what is that? It is p norm 18.82, p norm 18.82 comma 20 comma 3/5, right? I got that is 0.02461, and then I can do plus 1 minus p norm, and then you can do 21.176, right? And then comma 20 comma 3/5. If you do that, you get 0.496. That is 0.5, right? That's what you got. So that is 0.5. So which is basically same as the alpha, right? So this is the type 1 error, which is same as alpha. So type 1 error is always equals to the alpha value. Okay, guys. So see, this is very simple concept. Okay, but the definition is type 1 error is probability of rejecting the null hypothesis when H0 is true. Rejecting the null hypothesis when H0 is true, null hypothesis is true. When do you reject? You reject if the G is, probability of G is less than negative 1.96 and probability of G is greater than 1.96. Okay, when mu is equals to 20. That's what it means, right? Because for this given information, for alpha equals 0.05, you will be rejecting if the test statistic G falls left of negative 1.96, or because that will be the standard reason. Okay, or greater than 1.96. Now you just use the value of G, so x bar minus mu over sigma over root n. You do that one too. Okay, and then you will get the same value here. Again, as I mentioned, you can just change that to the G value, or you can find out that error here too. It's 0.05. You will get that. Okay, all right. So the type 2 error is defined as probability of not rejecting, right? You see that? Probability of not rejecting, don't reject R H sub 0, given that H sub 0 is false. Okay, so here we are testing the hypothesis for mu equals 20. So if this is false, then mu cannot be 20. Okay, if this is false, mu cannot be 20. Suppose that mu is equals to the true mean is equals to 22. Okay, we can assume that. Okay, so let's see that. Let me write down that when H0 is false, then mu cannot be 20, right? Let mu is equals to 22. Okay, so how do I write that then? Then the type 2 error, then the type 2 error is equals to probability of, don't reject the H0, don't reject H0 when mu is equals to false, means mu is equals 22. Instead of 20, mu is equals 22. Now when do you don't reject? Because we saw that in the type 1 error, we saw that we reject if x bar is less than that and x bar is greater than 21.176. But when do we don't reject is if G falls in the middle region, right? G falls in the middle region means X bar is greater than that and X bar is less than that. That means you can write probability that you can write 18.824 is less than X bar is less than 21.176 given that mu is equals to 22. Okay, now to find out this probability, again what you can do is you can do P norm, or you can change this to G, and then find out that. Okay, so either way you will use the P norm, but you can do it directly. How do I do that? Is you're trying to find out the area between 18.824 and 21.176 where the mean is 22, right? 22, so 18 may be somewhere here, 21 may be somewhere here. You're trying to find out that area. Okay, if you use the P norm, this is 21.176, this is 18.824, right? If you use the P norm, it will find out all the area left, but to find out the middle area, what you should do is you should do P norm of that minus P norm of that, right? So that's what I'm going to do here. So that will given as P norm of 21.176 with mean is 22. See, we are using mean 22 because that is the true mean. Okay, and then 3/5 is the sigma over root n, and then minus P norm of 18.824 comma, and then what do you get there? 22 comma 3/5. Okay, so if you do that in R, what do you get? You get P norm 21.176 comma 22 comma 3/5, right? And then minus P norm 18.824, is that what we have? 824 comma 22 comma 3/5. So what do you get? 0.8482. That's what you get. So that will be the 0.8484, okay, and then 82. That's what you get. 0.8482. That is the value of type 2 error, that is beta. So what will be the power? Oh, 0.08. Okay, so power will be 1 minus that, right? 1 minus beta. How much will be that power then? So the power here will be so you will have 1 minus that value. So 1 minus that value will be 0.9151. That is the power of this test. 0.9151. Okay, that is the power. Usually we take the type 1 error is 5% or maximum 10% of the type 1 error. Okay, alpha is maximum of 1.1 or 0.05 is the frequently used value. But for the power or the beta value, so the beta value usually it should be less than 0.2. That's the convention. Okay, so beta value must be less than 0.2. That means the power must be greater than 80%. All right, so next for the two-tailed test with null hypothesis is mu equals 20 versus mu not equals 20. The gray area is the rejection region 80. That gray area, that whole thing, and that thing under that blue curve, okay, is the rejection region. All right, so that will be the alpha value. Alpha is the sum of this plus that. That is the type 1 error. But when do you get the type 2 error? Type 2 error is there if the null hypothesis is not true. Okay, you fail to reject, but it is not true. Okay, so if 80 is false, that if this is not true, then assume that mu equals 22. In that case, that the normal distribution curve will be like that, right? On the mean there will be peak on the mean, so it is bell-shaped curve. Okay, symmetric about that 22 there. So the population distribution would be the red curve at that time. In this case, the rejection region under the red curve changes. You see that? So this value is now, so see this blue curve, the rejection region on the blue curve and the rejection region on the red curve are different here. You see that? Okay. So the sum of these two light yellow region, this region and then that region, are the probability of rejecting 80 when it is true. Okay, but how about that this middle region then? That middle region is the the type 2 error. Okay, so the outside is the power, and then that middle region is the type 2 error. So if you move this, if you slide this red curve, then what happens is you will get that this region will be bigger and bigger and bigger. That will be the power will be bigger and bigger, because that region, that whole region plus that region is the power. If you slide it, then this will be smaller and smaller and smaller, and that area will be bigger and bigger and bigger and bigger. Okay, meaning that if the true mean is far away from the hypothesized mean, then you will get the bigger power of the test. Okay guys, that's what it says. Okay, that's what in this section, in this slide says. The quantity 1 minus beta, because this middle quantity is beta, the outside quantity is 1 minus beta, is the probability of rejecting null hypothesis when it is false. Okay, it is called the power of the test. Power of the test is measured in percentage. For a given sample size n, or relatively small probability of type 1 error is associated with a relatively large probability of type 2 error. Okay, so if it is, if the type 1 error is small, meaning if that gray area is small like here and here, in that case that beta will have the bigger area, right? The white area will be bigger. That means, so the beta will be big, right? So relatively small probability of type 1 error is associated with relatively large probability of type 2 error. Usually alpha equals 0.05 is considered the small enough chance of committing the type 1 error, and beta equals to 0.20 is considered not too large chance of committing the type 2 error. Depending on the experiment problem, we may need higher power. Okay, so if the difference between a hypothesized mean and the true mean is large, meaning if you slide this curve bigger to the right or left, then you see that difference between the hypothesized mean and the true mean will be bigger and bigger. In that case, the power of the test will increase, because that area will be bigger at that time. The difference is denoted by delta. Delta is the difference between the true mean and the hypothesized mean. True mean and the hypothesized mean. One way of reducing the type 2 error, that is increasing the power 1 minus beta, is increase the type 1 error. So if you increase the type 1 error, that means that area will come here and that area will come here. At that time, type 2 error will be smaller and the 1 minus beta will be bigger. So another way for given alpha and population variance sigma square is increasing the sample size n. If you increase the sample size, then you can improve the power. Okay, the bigger sample size is associated with the smaller variance because of this standard error formula. Okay, because at that time standard error will be smaller, and this implies the narrower normal curve and thus a smaller type 2 error. If your variance is big, if your sample size is if you increase the sample size for a given variance and given alpha, then your normal curve will be a higher peak. At that time, your alpha value will be small. Okay, alpha value will be small, meaning that the power will be big. All right, guys, that's how it works. Okay, the next thing I want to do is how do I find a power of a test by using the R, because we just saw how do we calculate power of a test by hand. Okay, so to use R, what we need to do is you need to keep power equals to null. And also one of the very important thing about knowing how to find out power of a test is sometimes you may be wonder like how much what should be the sample size. So I want to conduct an observation or an experiment to study something, but what should be the sample size? To do the sample size, what you should try to do is you should try to consider what is your power, what power do you want to keep on that test, what should be the power of your test. You just think that, and then you can, based on that power, R will give you the sample size. Okay, so this is if you are finding the sample size, you write n equals to null. If you are finding the power, you will keep power equals to null. So to find out the power of a test, you need to install a package by copying and pasting this install package, and then inside the quotation PWR, and then you need to call library PWR. Okay, now to find out the power of the normal distribution test or the G test, this is the power of the G test. You do D equals to true value minus the hypothesized value, because true value was 22 in our case and the hypothesized value was 20, divided by the standard deviation, that is D. D is true value minus hypothesized value over standard deviation. N is 25, right? And power is null because we want to find out power. And significant level is 0.05. Alternative is two-sided. Okay. Then we calculate that power using that. Just run that code. I will show you in the R as well. This is what you get. So the power is 91.51%. That's how we find out the power here. Okay. Now let us do directly here using R. So what is, see, D is the difference of hypothesized and true mean divided by sigma, and power dot norm dot test. That's the syntax you use. D equals to that value, that by the definition. N is that, and power is null because you are finding power. Okay. And significant level is that, and alternative is two-sided. So if you run this, by the way, so why it is not running is because I need to call that library. So let me call the library and then run that code. I got, this is the power. Okay. For a given sample size, for a given difference between the true and true mean and the hypothesized mean, it gives you the power. Now, suppose if you want to find out the size of the sample needed to maintain a certain power, how do you do that? Is, look at this example. Power dot norm. I think I have that here. Okay. Find the minimum sample size needed for a two-tailed hypothesis test of mean width. Null hypothesis is this, alternative hypothesis is this, alpha is given, sigma is given, n is given, and power needs to be 0.85. Assuming that the true mean is mu equals to 77. Okay. So how do I find out that? Is to find out n, you should keep n equals to null, and power is given, you want to maintain 85% of the power of the test, right? And D is again the true mean minus hypothesized mean divided by 8, divided by the sigma. Okay. And then what you get here is, if you run this, you get the sample size. If you want to keep the power is 85%, then your sample size must be at least 144. That's what we got here. See, the rounded up value here is 144. That's how we find out the power. Now, this was the case when sigma was given. Okay. If sigma is not given, then you will have to use S, sample standard deviation here. Everything is same. Instead of power dot norm, you will have to do power dot t dot test. Okay. Instead of pwr dot norm dot test, you need to do power dot t dot test. So everything is same except that is S, the sample standard deviation. Okay. So if sample standard deviation is like 1.3, let me see if it is there. Okay. Look at that. This is the R syntax for that. Okay. For a t-test. And suppose that sample standard deviation is given as 1.3. Let us suppose. This is just the assumption. This is just an example, right? If you run that 22, and then suppose that the true value is 23. Suppose the true value is 23 and the hypothesized value is, suppose that the true value is 22, true mean is 22, and hypothesized mean is 23. Okay, and S is 1.3. This is just a random example I picked. And then N is 13. I'm just assuming that. And if you run this, you will get the power is 83%. 83% power. Okay. Now, if you want to find out, if you want to keep the power 92%, then what should be the sample size? So to do that, you just keep the power equals 0.92, and then N equals to null. If you run this, you will get power is 92%. The sample size must be at least 18 sample size in this problem. Okay, at least 18 should be the sample size if you want to increase the power. See, when the sample size increases, the power increase. You see that? It's the significant level, then the power will increase. For example, instead of 0.05, if you write just 1 and then find out the power of that problem, see, there is 92%. So previously it was 83%, right? 83.33%. Now if you change that, it will be 92%. So increasing the value of alpha basically increases the power. Okay, guys. So to find out the power of the proportion test, what you do here, you see that power of the test. This is the example that I just did. Okay, guys, this is the example I just did. Now I want to do another example with the power of the proportion test. This is how you do power.p.test, h equals to, you do es dot h, and then p1 is the true mean and p2 is the hypothesized mean, and n is the sample size significant level, and so on. Okay, so if, and then the alternative is greater, you can do two-sided, less than less or greater, it doesn't matter. Now see, this is the problem. You have in one sample proportion test is to be conducted using 25 subjects. For h sub 0 is p equals to 0.55, and h sub 1 is p is greater than 0.55, with alpha that, assuming that the true population, so true proportion here is 0.75. You see that? So for the true proportion 0.75, what it does is you write 0.75 here, you write 0.55 here, hypothesized mean, and then just run that. Okay, look at this one. So this one is for the proportion test, power.p.test. This one is also power.p.test. So this one here, I'm trying to find out the power. Here I'm trying to find out the sample size for a given power 88%. Okay, so let us run that. It gave me 83.47 power, and the second one I fixed the power, and I was trying to find out the sample size. It is 29 point, that is 30. You always round up. Okay guys.